Bismillah, alhamdulillah, wassalatu wassalamu ala rasulillah. One more point in section 9.5, Cramer's rule, but this time when using it to solve systems of linear equations in three variables. So three equations and three variables. Well, it is exactly similar to the same rules, similar to Cramer's rule when we solved two equations in two variables. You find three determinants, the determinants D. But this time the determinant D in which you write the coefficients of x, y, z, is a 3 by 3 determinant. That's the only difference. And in 2 by 2 linear systems, d, dx, dy were 2 by 2 determinants. Now you have 3 by 3 determinants. And how to find dx? You replace the first column, the column of x, you replace it by the constant terms or the constant numbers d1, d2, and d3. And dy, you replace the second column, the column of y, by the constants. And dz, you replace the third column, column of z, by the constants. For more information about Cramer's rule, please check the first video in this section. That's it. And x would be dx by dy, dy by d, and z dz by d. So here we evaluate four 3 by 3 determinants to solve the system. So for example, to use Cramer's rule to solve this system, I need to find first the determinants d. And the determinant d is the determinant of the coefficients. So these are the coefficients of x, coefficients of y, coefficients of z. Let us evaluate this determinant. Well, let me use the first column, 1, 1, 2, to expand this determinant. Remember the signs for the first column are plus, minus, plus. So 1 times the minor of 1, which is 4, negative 2, 3, and 1, minus 1 times the minor of 1, delete the row and the column. So 2 minus 1, 3, and 1. For more information about evaluating 3 by 3 determinants, see the previous video. And then plus 2 times, delete the row and the column. So I have 2 minus 1, 4, and minus 2. So I have 4 minus negative 6, negative 2 times 3, negative 6, so plus 6 minus 2 minus negative 3, so plus 3 plus 2 times negative 2 is negative 4 minus minus 4, so it's plus 4. So this determinant is 0. So I have 4 plus 6, 10 minus 5. So the determinant of D is 5. Okay, now let us find dx. I replace the first column by the constants. The constants are negative 4, negative 6, and 3. The second column and the third column, I do not do anything with them. Okay, this is the determinant, this is dx. Let us find dx. Choose any row or column to expand. Well, let me choose the last row. The signs are positive, negative, positive of the last row. So 3 times the minor of 3, delete the row and the column, minus 3, delete the row and the column, plus 1, delete the row and the column, Okay, so negative 2, 2 times negative 2 is negative 4 minus negative 4, so it's plus 4. So this is again 0. Minus 3 times negative 4 times negative 2 is 8. Minus negative 1 times negative 6 is 6. Negative 4 times 4 is negative 16. Minus negative 12 or plus 12. So this is 0. 8 minus 6 is 2. Negative 3 times 2 is negative 6. Here negative 16 plus 12 is negative 4. So dx is negative 10. X is dx over d. So negative 10 over 5. So x is negative 2. So we found x. Sometimes in the questions, because this is a long uh, exercise to solve, he will ask you in the exam, for example, find x, only find x, or find y. So in this case, you find dx only and dx over d. In case of y, you find dy and d, and then you find y. Well, dy, the determinant of y, I write again 1, 1, 2, the first column as it is, but I replace the second column in d by negative 4, negative 6, and 3, the constants. The third column, I write it as it is. So this is dy. Let me choose the first row. Okay, the signs for the first row, positive, negative, positive. So the first row is positive 1, so I'm not going to write it. Delete the row and the column. Then negative 4, so it would be positive 4. Delete the column and the row. Then positive negative 1, so it's negative. Delete the row and the column. Negative 6 minus negative 6, so it's positive 6, so that's 0. 1 minus negative 4, so it's positive 4. 1 times 3, negative, negative 12 or positive 12. So this is 0. This is 5. 4 times 5 is 20. And here 12 plus 3 is 15. 20 minus 15 is just 5. So what would be y? Y is dy over d. dy is 5 and d is 5. So y is 1. Let us find dz. The first column as it is. 2, 4, 3, the second column in d as it is. And the third column, I will replace it by negative 4, negative 6, 3, the constants. Which, let me choose the row, the column in the middle, okay? I'm just changing them because to let you know that everything, always you'll get the same answer. So what are the signs? Positive, negative, positive. So negative, positive, negative. So the signs for the second column are negative, positive, negative. So I have negative 2 times. Delete the row and the column of this 2. Okay. What do you get? I have 1, negative 6, 2, and 3. Then plus 4 times. And now delete the row and the column of 4. So I still have 1, -4, 2, and 3. And then minus 3, delete the row and the column of 3. So I have 1 minus 4, 1 minus 6. 3 minus -12. 1 times 3 is 3 minus -8. 1 times -6 is -6 minus -4. So 3 plus 12 is 15. -2 times 15 is -30. 3 plus 8 is 11. 4 times 11 is 44. -6 plus 4 is -2 times -3 is +6. 44 plus 6 is 50 minus 30, that's 20. So Z is dz over d. 20, d is 5, so Z is 4. So the solution set of this system consists of the ordered pair, ordered triple. X is -2, Y is 1, Z is 4, and that's the answer. I hope it's clear for you. I will leave this question for you. You find the determinant D, okay? This is the determinant D, and dx, this is the determinant dx, dy, and dz. So these are the 4 determinants. Evaluate each one of them, and then x would be dx over d, and y would be dy over d, and z would be dz over d, and you solve the system. Same here, okay? Please do this question. Use Cramer's rule to solve the system. And also here, do the same, okay? Practice by yourself. And let me give you the answers in case. Let me give you the answer here. The answer here is the ordered triple 2, -3, and 4. To check yourself, your answer. And the answer is 2 in 29 is -5, -2, and 7. And the answer in 31 is 2, -3, and 4. Let me solve this one with you. So use Cramer's rule to solve the system. Let us find D. D1, 0, 2. Coefficients of x, coefficient of y, 0, 2, 3. Coefficients of z, 2, -1, and 0. Let me find this determinant. Well, let me use the first column. The signs of the first column are positive, negative, positive. So it's 1 times 2 negative 1, 3, 0. There is no need to write the 0. Plus 2 times 0, 2, 2, and negative 1. So 0 minus minus 3, that's plus 3, plus 2 times 0 minus 4. 3 minus 8 is negative 5. So that's D. Now let us find dx. We replace 102 by 4, 5, 13. Let me use the first row. The first row, the signs are positive, negative, positive. So it's 4 times delete. When there are zeros, things would be somehow easier. 0, no need to write it, plus 2 times. So it's 4 times 0 minus minus 3 means plus 3. 5 times 3 is 15. 2 times 13 is 26. So 15 minus 26 is negative 11. And negative 11 times 2 is negative 22. And I have here 12. So 12 negative 22 is negative 10. This means that x is dx over d negative 10 over negative 5. That's 2. dy. I go to D, I write the first column as it is. I replace the column of y by 4, 5, 13. And I write the column of z. Now let me choose the first column or the last row. Okay, the last row, plus, minus, plus. So it's 2 times 4, 2, 5, negative 1, minus 13 times 1, 2, 0, negative 1. And the 0, no need to write it. So I have 2 times negative 4 minus 10 minus 13 times negative 1 minus 0. This is negative 14 times 2. This is negative 28. And this is positive 13. So the answer is negative 15. And y would be negative 15 over negative 5. So that's 3. dz finally. The first row as it is in D, 0 to 3 also as it is. And replace the last column by the first column, sorry, and first two columns the same as D, and write the constants in the last column. And also let me choose the first row. So 1 times the minor plus 4 times the minor. 2 times 13, 26 minus 15, 0 minus 4. 26 minus 15 is 11, minus 16, negative 5. So z is negative 5 over negative 5 because d is negative 5. So z is 1. So the solution set of this system would be x is 2, y is 3, and z is 1. Now some other type of questions. Write the system of linear equations for which Cramer's rule yields the given determinants. So if this is the determinant d and this is the determinant dx, when we use Cramer's rule, can you write the system? If you remember, what is we have the coefficients of x and the coefficients of y. So we know that the first equation is 2x minus 4y, and the second equation is 3x plus 4y. What are the constant terms? Well, you remember dx, how to find dx? We replace the coefficients of x by the constant terms. So these are the constant terms, and this is the system of linear equations. Solve for x. Well, this is a determinant. How to evaluate the determinant? Negative 2 times 6 is negative 12 minus 4. X equals 32. This is an equation. You solve it and find the value of x. 32 plus 12 is 44. So x would be 44 over negative 4. That's negative 11. Solve for x. Well, I evaluate the determinants. To evaluate the determinant, let me expand using the first column. So 1 times 1, 1 minus 2, 2. Delete the row and the column. The minor of 1. The minor of 3, but remember there is a negative sign. The minor of 3 is what? X, negative 2, negative 2, and 2. This should be equal to negative 8. So here 2 minus 2, so plus 2. Then minus 3 times 2x minus negative 2 times negative 2 is 4 equals negative 8. This is 4 if you take it to the other side. And if you expand here, negative 3 times 2, negative 6x. Negative 3 times negative 4 is 12. And here I have negative 8, and the 4, I took it to the other side, negative 4. So negative 8 minus 4 is negative 12. So negative 6x would be negative 12, negative 12, and x would be negative 24 over negative 6, which is 4. And that's the end of section 9.5. I hope you enjoyed dealing with determinants.